So for this problem, I want to work through a problem of designing Google Drive. This is a Google theme. Today we'll be just doing Google theme stuff. Why not? Um, so we're going to be
Hmm.
going through Google Drive, and so again, the main kind of functionality we want to implement here is we want users, obviously to be users, and we want users to be able to upload and download files, and to be able to share a link to a file.
Okay. All right. So if we can start off with some requirements, like you said, on the functional level, users can upload. All right. I can
Yes,
move this
thanks.
over there. So users can upload files. Um, Users can view and download files. And you said users can share links to files. On the non-functional side, I'm assuming um, thinking consistency over availability. I'm assuming we want our service to be available all the time on the consistency level. Like if somebody makes an edit to their file, if it takes a couple seconds or minutes to propagate through, is that a deal breaker or?
Yeah, availability I say is important for the API, but consistency is the most important
Mhm.
for the file read.
Okay.
In other words, we would rather a user not be able to download a file than to download an incorrect one. If it were, for example, overwritten,
Right.
right?
Okay. Hmm. Okay. Um, so thinking about some of the entities that we have here. So we have users. So that'll be, we'll give them like a username, um, some other data. We'll see as I go through if
Yeah.
there's more things. We have files. Um, so these we're storing files. So first thought that comes to mind is that we'll be using an object store for this. So I'm just gonna go with S3. So we'll have an S3 URL. Um, we'll give them an ID, and we want to be able to share files. So we'll probably have to generate um, some kind of share link that can be sent to people.
Okay.
Um, so our API, like we said, we want to be able to get some file, and this will be based on, yeah, so we want to be able to get a file, um, and this returns just the binary blob.
Mm-hmm.
We want to be able to post a file. Um, yeah, so it's gonna take in a binary file as well. Um, okay, so moving on to, I guess, starting the high level design. So we have our clients here. Uh, um, you said Google Drive, but I'm assuming we're just gonna work with the excuse me, the web interface, not like the syncing your local file
Yeah,
system.
just the web interface, like kind of like Dropbox, I suppose.
Just the
Like I
web
don't know if
interface.
Dropbox also syncs, but yeah, basically just the web interface. Yeah.
Okay. So we have a web interface. Um, move around. So this is gonna go to our web servers. Also, I guess I should
Mm-hmm.
ask before
Yeah.
I start our user counts and I guess on average how much storage they have or like how many files they're storing and what's the ratio of um, reading to writing files.
Yeah, so for this case, we can say we have 10 million active users, daily active users. And
Hmm.
what other question you had? Was it the file size?
Um, Average file size and how many files they're uploading a day.
The average file size we can assume is 100 megabytes. And we
Mm-hmm.
assume everyone uploads one file a day.
Megabyte uploads one file a day. One other thing is I like security. So managing access to files. For now, I'm just gonna say that's out of scope while I work on the rest of the design. And
Okay.
if we have time at the end, I
Yep,
can
that
come
sounds
back to
good.
that. Okay. So our web interface is gonna go to our web servers. So here, thinking about just the flow, we'll start with posting a file. So like in Dropbox, when we post a file, we're gonna want to add that to S3. S3, it's our object store. And before we do that, actually, we want to make sure, one thing I want to make sure is that we're avoiding duplication, but we can come back to that later. Something we can like hash files. But I'll continue with the basics beforehand. We're gonna want to store probably some metadata about the files too. Assuming everyone uploads one file a day, that's about 10 million uploads a day. So that's a lot of writes. So that's making me lean towards maybe a NoSQL database for storing the metadata.
Okay.
So we'll call that metadata DB. And so in our metadata, we can store things like in our files, we can store things like the share link. Also, you mentioned before, like we don't want them to download out-of-date files. So we'll want to keep track of the last updated, or yeah, something
Okay.
like that, like a timestamp. Yeah.
Is this a table? Is this a
So
files table in your metadata DB? Okay. And well,
yeah.
what's the primary key?
So it's yeah. The primary key would be I guess we can use like there's auto-generated IDs, but I think we can also use the S3 URL because that'll be unique per file.
Okay.
So that's our metadata database. Okay. So writing to that, when we write to the database as well, we'll also want to generate the share link. And that share link needs to be unique. So we can use, we can hash the so yeah, that share link is going to be generated, I guess, once per file. And so on creation, we're going to want to create that share link. We can create that using some kind of hashing function. We'll say MD5. So we'll generate the share link using hash function.
And this is on upload.
This is
Okay.
on upload. Yes, on upload. Um, and because, uh, like we said, sorry, we actually want to be able to update files as well. Um, we won't want to regenerate the share link because if it's already been shared, and we're just updating the file, we don't want people to, we don't want that share link to change.
Okay.
Okay. Okay, so that's the basis for uploading files. Now we're gonna want to get files. So assuming we're going off a share link, we're gonna want to query our database for that share link to be able to retrieve the S3 URL. So this is, we'll call this the upload service. And we'll make a new service for reading files. And then we can actually pass those through an API gateway based on whichever one we want to hit. Okay.
Okay.
So our read service, based on the share link, we're going to want to query our database to find the related S3 URL. And then, so that's going to hit, I guess I should move this. So I just moved this around. So yeah, so this is going to also hit our metadata database to find, based on the share link, find the S3 URL to hit, fetch that S3 URL, and then return that. So that's the basic flow. So one thing I'm thinking about right now is, let's say somebody, I don't know, uploads some, I don't know, some super popular file, and now everybody wants to hit that file. So we're gonna want to be able to cache that somehow. We could use a CDN because it might be region based as well. Let's say, I don't know, for an example, but let's say there's some super popular file that's just been uploaded and is being shared everywhere in Vancouver. So everybody's going to want to be able to get that file. So we'll have a CDN for caching super popular files. And so should be the other way around. Oops. Yeah, so our when we first when somebody hits the some share link, check if it's in the CDN, and if it's not, then continue on to the read service. And the read service will, based on how many times it's been fetched, we'll update our CDN with the S3. We could determine some qualities for this based on how many reads are being done per region, and I don't know, within X amount of time. We probably don't want to store everything in there, only the most popular files, because users are going to be downloading files anyways, and so it's not super critical that everything happens we're not working on like millisecond timescales.
So where is this? So you mentioned the heuristic for updating the CDN is based on the read count of a share link,
Hmm.
and where will we be storing that information? So how will the read service know to update that?
Right. Right. That'll have to be also stored along with in the file metadata. Um, yeah.
Okay.
I guess um, because because actually we want it to be recent read counts, not just all time all time read counts. We'd need to handle that kind of separately. Um, we need some type of way to associate, um, I guess within the last, let's say, 24 hours. Uh, so we could have, um, I'm thinking we could have another table for counts, um, based on a share link, uh, that tracks for 24 hours and then gets reset every day.
Why does it need to be reset every day?
Mm. Um, because like if we have some some file that has like a super huge spike, and now it has like let's say 100,000 reads, um, and we're only caching on the total read count. In like a year from now, if there's other files that are popular but maybe haven't hit that level of popularity, that's going to stay in the cache, I guess, indefinitely, even though nobody's accessing it anymore. And so, um, this is kind of hinting to me that we have some kind of relation between these. Uh, so, like accounts would have based on a share link, and then a view count, and then we can run a cron job. I would say every 24 hours to reset it.
Okay. We can do that. Is there if you're running a cron job to reset every 24 hours, why do you need a table for that?
Right. Yeah, I guess we could just upload it. Sorry, update it in the database itself.
Yeah, so I guess you're saying in this case it would be every 24 hours you just wipe this read count to 0 for all items in the table.
Mm-hmm.
Okay. That would roughly work.
Actually, now that I'm now that I think more about it, we could make use of something like Redis and have it, because we can set it to expire after 24 hours. So instead of having a CDN, actually, we can just have this be a Redis cache that will cache the share link. That's going to be our key, and the value is going to be the S3. It's going to be based on like count and an S3 URL. And so every time we read, actually no. I'm just thinking about every time we read, we need to keep track of that count still somehow. I'm not sure if with one, assuming everyone uploads one file a day, that's 10 million files daily. I think that's gonna be too much to keep track of in just Redis. So actually, I'm gonna backtrack on that and go back to actually, I think we can keep Redis because it's cheaper than a CDN, but the keeping track of the counts will still have to be will still be done in the metadata
Can you
database.
just quickly go over again why you don't why or I think so you previously were trying to track count in Redis, was it? Okay, can
Yeah.
you just go over why that's not feasible in this case? I'd missed that part.
I'm just thinking with 10 million
Mm-hmm.
daily active users uploading one file a day, that's 10 million
Yeah.
files a day. Assuming somebody's uploading them and reading them, uh, there's going to be millions of files being read.
Not necessarily.
Um,
I didn't
and
specify the read ratio.
mm, okay, that's
Most
fair
files
actually.
most
Yeah,
files
I
are just
was
uploaded, not read.
okay. If most files are just uploaded
Mm-hmm.
and not read, yeah, I guess I should have clarified the assumption that the files were being read um, at least once per day, but that's actually not true. And yeah, with our expiration of one day, the cache is going to be cleared. So so files that are only being read like in one day, it's going to be gone the next day out of the cache actually. So that does work. So we're gonna in Redis we're gonna cache share link as our key, and that's gonna have the S3 URL and the read count that we can update. Um, and then also the last thing um, is updating files. So uh, putting putting files that will also be directed to our upload service, and that can just um, update. It'll fetch the S3 URL,
Mm-hmm.
um, and then update that S3 URL with
Is this
Amazon.
so? Was this which flow was this for?
This is for
Okay, yeah.
put for updating a file. Um, let's see, and then I just want to make sure that we need to make sure that people don't download um, the wrong version. So that's going to update the last updated
Mm-hmm.
as well. Um, I'm not sure. Does S3 just give you when you query? Does it just like give you the straight like data,
Uh,
or does it give you some metadata
it can
associated
give
to
you
it as
either.
well? Okay, so yeah, we'll want to um, when we upload
Mm-hmm.
to S3 and we update the last updated, um, that'll keep track of what the new file is. And so when we read, and we get we fetch from S3, we'll want to make sure that the last updated the metadata that we get about the last updated matches with our database. And if not, we'll return them an error
Um,
and they can retry.
this is for the read consistency between Redis and S3. Was it? I'm not quite clear on how that solves. I'm not quite clear on the problem that solves.
Yeah, this is for read consistency between
Mm-hmm.
and um, the user and the S3 file. So Redis is
Yep.
caching the S3 URL so that we don't have to look it up in
Mm-hmm.
the metadatabase. Um, and then once we fetch from S3, we just compare the updated
Yeah.
day or like updated
Mm-hmm.
timestamp with what we have in the database. If they don't match, then we have an outdated version. Um, from we have an outdated version, and then we can have them
Can
retry
you
again.
explain a scenario where they might not match? In other
Um,
words, right now the only time that you write to these is the upload service, and it always writes to both.
mhm,
That's by what you're saying so far.
right.
So can you describe a scenario where these
Yeah.
two, the last updated in your table, and the S3 metadata might not match, or is that a not possible scenario?
Actually, I guess that is not possible, because I think uh, I guess S3 will handle that um, part of it. Like as long as if we've successfully uploaded to S3, then any consecutive fetches from there will always be of the new file. And so as long as we update our last updated conditional, like after S3 has successfully uploaded, I guess there won't be that um, that case of it being out of sync.
What about the scenario where we're uploading a large file? Because you said your average file is 100 megabytes, but there could be larger. So let's say we're uploading a very large
Mm-hmm.
file to the upload service.
Yep.
What will that look like?
Mm. Yeah. So if we, yeah, if we're uploading a large file, um, it'll take a long time, and uh, if our connection breaks or something in the meantime, um, then we'll lose all our
We can assume
progress.
that your upload service somehow handles retries to S3. But I want to discuss.
Okay.
So, what is the first thing the upload service will do if it receives a large file, or any file really? But this scenario, we're talking about large files.
It's the
Yeah.
first thing it'll
Like,
do.
what's it gonna do?
Uh, well, the first thing is to generate the
Okay.
link. Um,
Well, you only generate a link if it's not overwriting something else, right? Okay. Sure.
yeah.
Yeah. Let's say it's like let's say it is overwriting something else. So it's a large file that's
Mhm.
overwriting a previously small file or whatever.
Yeah.
So what? So you don't need to generate the link. Do you write to the database first, or do you try to write to S3 first?
We try to write to S3
Okay.
first, um, because we don't want to update our last updated if it's not actually been successfully uploaded into S3.
Okay. So let's say while it's uploading to S3, it's doing stuff. In this scenario,
Mm-hmm.
during this while it's uploading, if someone were to read the file, what would happen?
Mm. Um, yeah, I guess they would have, um, they would be reading the old version of the file if the upload isn't done yet.
Mm-hmm. Yep.
So, um, so the ways we could do this would be, either we update the last updated and we roll back on failure, or uh, we can add a field like updating or something,
Mm-hmm.
and then um, change that. I think they're kind of equivalent either way, so I'll just go with we'll update the last
Okay.
updated. So on upload, we update the files last updated and roll back on failure.
Okay. Yeah. So in this case, right. So let's say we have this now. So now we have a large file writing a different file or the previous file. We update our last updated. Now someone tries to read it. Now what happens?
So yeah, now someone will try to read it, and then S3 will give them the old
Mm-hmm.
version, um, so that will have the old last updated, um, and then when we compare that with the last updated, um, and that will be out of sync, and so they'll will return an error response to them.
Okay. What if this file is cache and redis?
Um, so I don't the the idea wasn't um, to cache the file
Well, you would cache the URL.
itself.
Yeah. Yeah.
In Redis, yeah, we're caching the S3 URL. So that would um, end in the same way,
Okay,
I
so
think.
we're assuming the URL you can get the metadata, like the same last updated field from. Is that the assumption you're making here? We're assuming that we
Sorry?
could also receive the last updated information of S3 from this. Okay.
Yeah.
How can you
Yeah.
explain a bit more about how that flow is gonna work? So this file, so this path, right? This path is in Redis. So the read
Hmm.
service finds it, and then what?
So the red service finds it. Sorry, the read service finds it in
Yep.
Redis, um, and then mm, and then and then it fetches like the S3 to pass it back to the
Okay.
user.
Where is it gonna check the last updated?
After after it
Uh
fetches
huh.
from S3. So like we said, if S3 returns
Yeah.
the metadata about about
Yeah.
the file, so it'll get the S3
Mm-hmm.
URL from Redis, fetch from Redis, verify. Um, Actually, that defeats the point of the cache. So we should actually have a last updated in here as well. Actually, that's more complexity because we'll have to update the cache as well um, on update. Yeah, I'm thinking like it'll fetch the read service will fetch from S3 and then compare that with
Mm-hmm.
the database.
So you want to avoid reading the database if it's in cache. That's the point.
Hmm. Yeah. So we'll have to have a last updated in here, which means that um, our upload service will have to also update. Um, we'll also have to manage updating Redis as well, based on uh, it. It'll look in Redis if the share link is a key is present in there, and then it'll have to update the last
Yeah.
updated as well.
We can go with that for now. Yeah, that's fine. Okay. Let me just quickly look over that. Okay, it makes sense. Um, okay, are there anything? So let me just take a look. So this is you said on if upload fails, we roll back the last updated in this metadata DB and Redis. Okay.
Mhm.
Um, is there anything else does anyone want to talk about before we move on?
Um, so we covered
Mm-hmm.
uploading files, downloading files, and caching for popular files. Sharing links to files is the same thing. Um, I guess is there a difference between like if a user gets their own files versus a shared link, or like when we upload, do we just return them, or like when they access their files, it'll be through that quote unquote share link anyways?
So, sorry, can you repeat the question?
Like, is there a difference between like a share link and um, like somebody accessing it through their own drive, let's say in Google Drive?
Functionally, no.
Or can we just pretend? Yeah, can we just pretend? Can we just say that like when we upload, um, like from then on, it'll only be accessed through that share link?
Well, it could also be accessed through the user's own navigation. The share link is like a one-stop shop
Hmm.
to get there immediately.
Right. So, like, I'm thinking now if there's a difference between um, the share link and how the user gets it from their own, like their own
Mm-hmm.
drive, let's say, because right now all our stuff is based on the share link.
It is based on the share link, but we're
So,
assuming that like behind this web interface, right? This is Google Drive interface, and the
mhm,
user. I think you said we're skipping the user detail here, which is fine. Um, that the user
yeah.
will eventually make a read request, like a get file that corresponds to their file,
Hmm.
which is fine.
Okay.
Yeah, I don't think that's going to be an issue in this case. Um,
Okay.
okay, cool. One thing I wanted to talk about this case, in this context now is in our given design, right? So we have some requirements here. Which of these pieces do you think will be the bottleneck? In other words, if you were to scale this design up, which piece would fail first?
Um, we we didn't. I guess we didn't clearly define what the read write ratio
Mm-hmm.
would be. Um, I'm assuming there would be. Uh, would there be a lot more reads than writes?
Over the lifetime of the file, yes, but not
Hmm.
necessarily in a day. Yeah.
Not
So
necessarily in a
the
day.
read and write of a
Right.
file can be destroyed in time.
Hmm. So reading, um, to me, reading the file seems like it would be less prone to
Mm-hmm.
failing first because we're just fetching from S3. I think the upload service is going to be the more um, bottlenecked one, just because uploading also
Yeah.
could take longer. Um, and so we could scale that out um, to have multiple instances
Multiple instances in terms of having.
of the
Okay.
service itself. So we could run multiple uploads
Can
concurrently.
you sketch out roughly
Um,
what that would look like? So you just have multiple upload services, and how would you split the work
yeah.
between them?
So we could load balance based on um, mm, let's see. So we could split it based on like um, we could just round robin
Mm-hmm.
the uploads because we like there's not really a need for preserving like order or anything like that. Um, and yeah, to me it doesn't seem like there's any special restraints requirements there, so we could just split them up. We could also um, split them up by region, um, just for locality, but that doesn't make a huge difference in the grand scheme of
Mm-hmm.
things, I think.
Is there any issue with two different services getting back-to-back requests to update the same file, or is that not an issue,
Mm,
or can you avoid it?
right. Yeah, we would want the updates to be ordered. So we could also split. We could split based on like a hash of the share link, so that requests go to the same server for the same file.
Mm-hmm. Yep, that would work. Is there a way you can? Well, in this case, we can also make the assumption that the only person that can update or can call the upload service for a given file is the owner of the user, is a user essentially. And so you could also shard it based on the user in
Hmm.
this case. So let's assume we go with that. We shard it based on the user ID. Um,
Right.
okay, one more follow up here then. If you wanted to extend the service by having multiple share links, so for example, you can give certain people a share link, give some other people a share link, and you can revoke them separately.
Hmm.
What sort of additional feature would we need or functionality would we need for that to accomplish that?
Um, so we're gonna have different share links. Let's see.
Yeah, like
So
in other
right
words, the
now, all of
user there's
our
additional functionality now, right, where the user can create multiple share links and delete previous share links.
Yeah. So we can create create a new entity, like a
Mm-hmm.
share link entity. So that'll have our URL, and then the point to the actual file that it's supposed to that that it that it like points to. And then when we delete those, we can just mark them as deleted in our database. And then if people try to access those URLs, then we'll return them an error.
Okay. Yeah. Yeah, that's feasible. So in this case, we're just we'll make a new table. Is it a table for share links? Okay.
Yeah.
And what's the primary key for this table?
Um, the primary key would be the
Okay.
link itself, and then it would, um, yeah, it would, I guess, join on the S3 URL.
Yeah, that's fine. Okay. Um, all right. Is there anything else in design you want to chat about? Otherwise, we're gonna go through some feedback.
I think that's all I
Okay.
got for
Awesome.
now.
Okay, let's end it here then. Want to talk to you a little bit about some of the things we kind of went through here. There's a couple of good things I want to talk about and some improvements.
Mm-hmm.
First of all, you just start these off with, how do you feel about the design? Do you feel like you've hit the main points here? Do you feel like there's certain things that you aren't confident on, etc.?
Um, I feel like I've gotten like the base of it. I feel like I might not have the best design in terms of like
Okay.
scalability. I feel like it's pretty basic, and I feel like I missed something at some
Right.
point.
Okay. Yeah, I think in general, right, like the pieces are there, right? The pieces are there, and the process I think you had is also fine. Um, just kind of starting off with the process, I guess we can. It's good that you start off the requirements, right? Functional and non-functional requirements. That's always a good thing to start with. One thing I will say though is that it's generally a good idea to also include the performance numbers in the non-functional requirements, just to kind of solidify that
Okay.
ahead of time, right? Because in this case, right, I didn't give you some critical information such as the read-write ratio and some things like the read-write
Yeah.
rate, which I guess is the same thing as the ratio and write rate, but like these are things that you kind of got to know beforehand to design your feature, right? Otherwise, you aren't really guided in what's
Mm-hmm.
going on here. So that should be part
Yeah.
of your non-functional requirements, in general. So just keep that in mind. Um, Entities wise, this is where it's good to kind of specify how you're thinking about the data, right? So these are, in one hand, these are also nodes, but you could also extend these to essentially be table schemas, right? So here you're using you think it's a document DB store, that's fine. Um, no matter what store you're using, there's going to be a primary key, right? So it's good to think about which of these fields is going to be unique per item, and just kind of marking that out as such. This is essentially a good time for you to kind of check that with the interviewer to make sure you're aligned on your assumptions, right? So this is a good time for that. One thing I will say is that I did say that we had to add users here, but because you also said that you're not going to worry about security, this becomes less relevant. But for example, there are still some
Mm-hmm.
times where you want to, you still want to be careful about this because, for example, in this case, every file is going to have an a user like an uploader. So even if you're not going through stuff like
Yeah.
security, it's still good to indicate that you're aware of these things, and we're just skipping that kind of side. So if you're gonna make table
Mm-hmm.
schemas, I know this isn't a schema, but over here's a schema. You want to put in stuff such as like uploader here, or like user, something like that. Yeah. Otherwise,
Okay.
that might be counted as a miss because it's technically the design wouldn't work unless you had the right user, right? Because then anyone could write. So you have to have a way to do that, even if you're not explicitly writing
Yeah.
the arrows. Um, get post put these are fine. These are good. I will say that you should just writing the header is okay, but you should check with the interviewer if they also expect the shape. So for example, what query, what parameters,
Okay.
headers, like I said, what else you might need, because sometimes this part of the problem is substantial, and it's good to just check your assumption about whether or not we need to go into detail here, or if we can skip it and focus on something else, or if we need to come back, right? So
Okay.
even if you think it's easy, it's good to just check that with the interviewer, make sure you can move on. Just asking something like, oh, is this API definition okay? Do we need to go into more detail, etc. Something like that. Okay.
Yeah.
What else do I have here? Okay, that's fine. Yeah. Okay. So the actual design itself. So this is one thing which I will say is that it's totally okay to just write out the components that you did initially. That's fine. That's good, right? One thing you do have to think about though is in this thing I had to kind of. So the first thing was you added a cache, right? You had a CD and you added a cache. Now, while that's usually a pretty good idea, that actually you did that before fulfilling all of the functional requirements. And as you notice, latency is not a requirement, right? So you started working on optimizations before all the functional requirements were actually met or non-functional. So the detail here is that this is like a time management risk, right? Because you start working on things that weren't part of the problem before solving everything, right? The thing, by the way, was that we need to ensure file consistency. And depending on how far your interviewer wanted to go on consistency as a topic, you might have run out of time, right? And also, right, because you added the cache ahead of time, now your consistency work has to take that into account, even if it's ugly, right? So that's something you have to keep in mind, right? So make sure, so before you work on stuff like that, just always remind yourself what you committed to in your functional and non-functional requirements. And when you think you met them, you should check. Hey, do we think that all these requirements are met? I'm going to work on improving the read path if you think so, right? So it's good to just check in that you've actually hit the kind of points first before moving on there. Okay. And then the next thing is regarding the cache itself. So I know you were kind of ping-ponging back and forth a bit. The correct, I wouldn't say correct way. There's a couple ways to do this. The programmatic way, and I would say people would generally think is the correct, or I want to go as far as say optimal, but one of the correct ways to do this is if you're using Redis, by the way. So, generally speaking, you should use quote unquote name brand products if you know a bit about them, right? If you don't know much about Redis, I don't know if you know much about Redis. If you don't know much about Redis, then you should just say just generic cache such as Redis, because if you actually put in Redis there, and you don't use the Redis features which solve this problem, then it's a bit of a yellow flag, right? Because it's like, oh, this person knows of Redis but doesn't actually know anything about it. So the use case here that you need to use was called volatile LFU. Volatile LFU solves this problem entirely, and this is something which if you don't know of that specific terminology, you can at least say, oh, I know Redis has an LFU eviction policy, and I know it has expiration policies, and you can combine them and just make that happen, right? So that's something which I would probably brush up on if you're going to talk about caching and CDNs a lot, because that's going to come up again, right? And so in this case, the fact that you said Redis and then you didn't immediately go like, okay, we're using this is because we're going by count. That's a least frequently used algorithm. That's count, right? And we want an eviction policy, which means that we want expiry, which is volatile LFU, right? So you kind of got there one way or another at the end. But having for example, a bunch of read services comparing stuff here and there, and having to store, like for example, explicitly storing the read count and last updated, that doesn't give confidence to the interviewer that you actually know how Redis works. So that is something which you should brush up on for caching in general. I mean, the solution would work, but it's just one of those things, right? Like one of those details for polish. Okay. Let's see. What is this? Timestamp matching. Yeah. So large file. So this is another thing, right? Generally speaking, if an interviewer is asking you, how about this scenario, that's usually something which doesn't work, and you should think about what doesn't work, right? So in this case, and this usually happens. For example, if you have a component like upload service, for example, which has multiple actions. In this case, it has 3 actions, right? An obvious question is like, what is the order of these 3 actions? Well, you actually had 4 actions, because this also produced a share link, right? So it actually has 4 actions. So you should always be clear in your head. If you're drawing multiple arrows, you should always think, oh, I already have an arrow. I'm drawing a second one. What is the order of operations here, right? Because the order of operations is actually very, very critical. In this case, for example, a large file example, right? If someone reads during the write, what would the behavior be? How can we ensure it's correct? right? So that is something which you should always be keeping in the back of your mind. And if you don't realize what's going on, then you kind of land yourself in a trap, right? So that's something you
Yeah.
just got to be careful of. Because remember, like, consistency is a requirement there, and you did not fulfill that, so that would be incorrect. But you did fix it,
Hmm.
but that would be incorrect, right? So just keep that in mind, right? Um, Last piece of feedback here
Yep.
was about the uploading service, about or in general about what's the first component to fail. That's a bit of a trick question because you cannot know that without knowing the performance requirements, right? And so,
Mm.
but okay, sure, we can assume that the upload service fails first. That's a pretty reasonable assumption. That's usually what would fail first because that's usually the most overloaded service as it does the most stuff. Um, one thing that I would one thing I would recommend in this case is this is a more so first of all this sharding it is fine, right? Sharding it based on users is a specific thing we're looking for, because right, remember, right, all of a user's items are can be in an S3 bucket, right? And so that way and so therefore what you should say is that because we're sharding it based on users, and all of a user's data is within an S3 bucket, which I assume is the case, but you don't actually say nothing about it. Therefore, we maximize the parallels writes to S3, which maximizes performance, right? So that's the kind of detail that you need to talk about, right? That is a bit more advanced, but that is a thing. Regardless, I want to mention the other thing I wanted to mention was about the uploads, the anatomy of the upload service itself, right? So I think what you've written here is pretty acceptable for new grad level, but one thing you can really differentiate yourself is by recognizing that the upload service is actually two services, right? The first thing it does is it needs to upload the metadata, which requires the generate link, the share link, and it needs to also evict from the cache, or update the last updated in the cache, right? That's the first thing it has to do, and those things are all relatively fast, right? Those things take a fixed amount of time, right?
Hmm.
The second thing it has to do, which takes an indeterminate amount of time, is that it needs to upload the blob to S3. And so one thing you should be thinking about at this point is about separating the update metadata service and the upload service, because those two things actually do kind of different things at the end of the day, right? And so, for example, if I just sketch this out really quickly here, right? You can have an upload service here, and it passes off files to an upload service. Let me see. Let me do this. Why can't I type? Yeah, I'll do this. Wait, why can't I type? Can I type over here? Oh, I can type here. I don't know why. That's kind of weird. Move it in. Yeah. Right. So this is one of those things where is a bit of a detail, but could help. Is that this way? Basically, the detail is that now we don't need to rely on right now we don't need to couple the updated metadata to uploading, because uploading is much more prone to failure, right? It's much more prone to being blocked on various things, right? This way, you can see what's going on is that we can specifically, where can I get a box? We can specifically scale this service way more, because this is the bottleneck, right? This is the bottleneck.
Yeah.
So that way we can use fewer servers because we have to isolate the bottleneck thing to scale only that instead. That's the detail here, which will bring the design to the next level. This wouldn't be here. Okay. That brings us to about time. Were there any kind of questions you had in general about the process or about your question?
No, I think this all makes a lot of sense.
Okay. Cool. Well, thanks for participating. I'll head out to the next candidate then. Thank you very much for joining.